Hi everyone. So last time I've walked you through the basic of a matrix, how a matrix is defined and how do we call an elements of a matrix. So today I'll be covering some basic operations of matrix. Right. So we start with the addition operation. So this operations only happens when we have two matrix A and B which the same size. Right, so let's say that A and B has m rows and n columns. Right, so we define the addition of A and B as a matrix C, which has also m rows and n columns. And each of the elements of C is the addition of the two corresponding elements from A and B. Right, so that is the addition operation. Then we have the scalar multiplication. Right, so supposedly we have a matrix A which can have whatever size it want to have, has j rows and I columns, and matrix A looks something like this: A1 to AJ, A11 to AJ1 to A1I, AJY. Right, and then we have a scalar, which is basically a number, we can say that it's a number, a scalar. Then the scalar multiplication of a k and a, which is ka, is another we can say another matrix, but is equal to, has the same size as A, but each of the elements is exactly k times the original elements. Right, so the new matrix is going to look like this. And k can be whatever values it want to be. It doesn't have to be strictly like integer or complex or real values number. It can take on whatever values it wants. Then we comes to the dot product. So dot product is a operations that happens between only two vectors, a column vector and also a row vector. So the condition is that these two vectors have the same amount of element. Right, and so about the order of the multiplication of the dot product. So if we have A as a vector, which is A1 to AM, then the B vector is a column vector, but it also has to have exactly m elements, right? And so there's only the dot product between A and B, but there's no dot product between B and A. And the dot product of A and B is calculated, wait, let me write this again. Right, is the sum of the corresponding multiplication between each element. So it's about A1 times B1 plus A2 times B2 all the way to AM times BM. Right, so we can write it in a shorter form, which is A I over 1 to M A Y B Y. Right, so now that we have grasped the basic of the dot product, we can finally move on to the most fundamental operation, which is the matrix multiplication. Right, so this happens between two matrices A and B. So suppose matrix A has n rows and n columns. B has C rows and D columns. So the requirement for the matrix multiplication A times B is valid is that N is equal to C, right? So then if A and B wants to be able to be multiplied, then A has M rows, N columns, which is size M by N, and then B has N rows. And what kind of column? D columns, which is the size of N by D. So the matrix multiplication A times B is defined as a matrix, G, which has the size of M and D. And so the elements of G is defined as follow. So G, let me write down first. G11, GM1, G1D, and then GMD. Right, so each element of G, Gij, is the dot product of the yth row vector of A dot product with the jth column vector of B, which is practically a y1, a y2, all the way to a yn times b1j, all the way to b and j. And it's gonna equal ai1 times b1j plus ay2 times b2j, all the way to ayn times b and j. And we can simplify it by writing a times what can I take as a denotation? L equals 1 to n of a times il times b of l of j. Right, so this is practically all the basic operations of a matrix. And so the most important ones in AI and also machine learning is the matrix multiplication, because once we get further into the computation part, we see that we often store numbers in arrays and also matrix. And so by performing matrix multiplication, it is performed much faster and more efficient. So that's it for today's episode. I'll see you guys then.